Critical numbers. This is from section 3.1 on our book, but it really applies to the whole chapter. Actually, we're going to start at section 3.3. So that's what we called. I'm just going to work on the definition of a critical number, and it's very simple. It's the x value that a derivative is 0 or undefined. However, it must be defined in the original function. Therefore, if it's not defined in the original function, it can't be called a critical number. You'll see that in the second example. So here's two quick examples. It's really simple. To determine the critical numbers of this first one, again, you have to find where the derivative equals 0 or is undefined. So obviously, the first thing you do is find the derivative. This is a simple power rule. This is 2/3 x to the negative 1/3, which is 2 over 3x to the positive 1/3. So this derivative is not 0 anywhere, but it is undefined at x equals 0 on the bottom. So the last thing you want to do is make sure that this is defining the original function, which it is, because that would just make the original function 3. So this means that's a critical number, because again, it made the first derivative undefined and yet also the original function defined. The second problem, we're going to find the critical numbers again, and so we have to find the derivative. This is a quotient rule. So the derivative is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Simplify the top, and you get the derivative is, distribute this, 2x squared plus 2x minus x squared simplifying, we have 2x squared minus x squared, which is x squared, plus 2x. And finally, I'm going to factor the top just to make it easier to solve. So our derivative is x times x plus 2 times x plus 1. So you all know how to take derivatives. That's not really the important part. You may want to practice that though. Now we have to identify critical numbers. So critical numbers again happen where the first derivative is 0. And this derivative, since it's a fraction, is 0 where the top equals 0, x equals 0, x equals negative 2, or where the derivative is undefined. And this derivative is undefined at x equals negative 1. So here's the little nuance to this. Your critical numbers must be defined in the original function, which is here. And if you look at that last critical number, x equals negative 1, it's not defined in this function because it makes that original function 0 on the bottom. So it's not a critical number. So it's only these two that made the first derivative 0. And that's critical numbers.